Okay, so good evening, guys. So welcome to our day 4 session. So today we are going to start with the Linux, right? So today is day 4 session, and today's date is 22nd of July, and the timing is 9:07 p.m. IST, right? So in the day 3 session, yeah, guys, any doubts you have? Anything? Yeah, sure. So in a day 3 session, we had covered on creating our own AWS account. So that's what we did. And also like we try to learn like how we can create our first virtual machine, right? So I hope that in this weekend, you all have practiced that. And if you have any doubts, you can ask me later on that. Anyhow, we are going to do it today again because we have to create the virtual machine one more time to do some practice. Right, but this time I'll be very fast because I'll not be explaining everything. So, but anyhow, everyone will get to know about what exactly I'm doing or how to create a virtual machine in our AWS account. Okay, so guys, what we are going to do today. So our main agenda for this week, this entire week, the agenda for entire week for this week to cover up Linux. Linux is a very vast topic. We can't really cover in 1 week, but whatever we had discussed earlier, right, when it comes to Linux, right? So all those topics or all those basic fundamentals and few more extra topics, whatever is there, that we are going to cover up on the Linux part. So I'll try my best to cover up to this week, but if in case if it exceeds with 1 or 2 sessions, right? So I will try to conduct in this weekend. So that's what I said that I requested for you all to come and attend on Saturday and Sunday also, right? So we were going to cover even on weekend also. Now, so guys, what the first question is that like what is Linux is all about and why being a DevOps engineer we have to learn Linux, right? That's the first question. So we know very well that Linux is a operating system, right? Linux is an operating system. Linux is like a Unix operating system. Linux operating system is like a Unix operating system, right? You know, like we had a traditional Unix operating system, right? In 1975 or 1979, during that period, Unix operating system was designed, right? And it was like most of the organization were using Unix operating system, and the Unix operating system was very favorable because whatever the features which the end user requires, right? They used to get all those features into the from the Unix operating system. So as the time progressed, right, many other different flavors of Unix operating system came. Even Windows operating system also came, and finally, what happened, right? We used to see that we had a multiple different types of operating system, right, in the market, and many of the customers, right, or many of the companies, they, according to the requirement, they were choosing that operating system. Say, for example, some companies were using Unix operating system, some companies were using Sun Microsystems Solaris operating system. Some companies were using IBM AX operating system. Some other companies were using HP like UX operating system, which is from the HP company. So there are a lot of different flavors of Unix operating systems were there at that time. So, and even Windows was there, and even Mac OS was also there. So there are plenty of operating systems which were there in the market. Now, so later after some time, I might tell now itself, like for example, 1991 or 1992, Linux operating system was evolved actually. So Linux operating system is like a Unix operating system. It's like a ditto like a Unix operating system, we say. So during that time, what happened, right? There is something like most of this Unix flavor or Unix based operating system were proprietary operating system. It means that you need to pay a licensing cost, right? So it was not freely available. And the main part is that actually many of the Unix flavors or different types of Unix operating system, there was certain hardware configuration or there, some processor type you need to buy. And on top of that only you can install the Unix operating system. You cannot install in any other like for example x86 64 processor. You cannot install it actually. Later when the Linux was evolved, right, Linux was targeted or it was targeted onto the x86 platform. So x86 platform processor, right, it was available in the market and a lot of people were using x86 processor. Say for example in our laptops and all, right, when we used to install Windows and all, we were working on Windows like that. Many other operating system we can install in x86. So later what happened, right? when the Linux was designed and it was released to the market, right? They targeted firstly onto the x86 processor only, right? Onto the x86 servers machines. So Linux is an open source. We say we'll try to understand what is an open source all about later. So now, when the Linux was evolved, like it was completely free. It means that there is no, you need not to pay any amount or any fee for your licensing cost. It was freely available. Anybody can download or anybody can install the Linux operating system and they can freely work into the system, right? And the Linux was like a Unix, as I said, whatever the features which you had on traditional Unix or some other different flavors of Unix, you used to get all those features even in Linux also. So that's what I said, like it is ditto like a Unix operating system. So who designed it? What was the purpose of getting it? That all there's a big story behind that. We will discuss it later on. Now, when the Linux came into the market, Linux actually captured a market because you got an other alternative instead of you going and buying any proprietary operating system like your HPUX or IBM-AX or Solaris, which involved a huge cost in licensing, as well as you need to purchase big hardwares, right, for that. So Linux became an alternative, and in the industry many of the companies they started switching to the Linux, and people started using Linux heavily. And slowly what happened, right, Linux community was grown, and lot of people will become a contributor on Linux operating system, and many people around the globe they started giving a lot of support on Linux also. So like that way the community and a lot of things were growing on Linux platform, hence Linux become very favorable, right? So I mean in the year like 1998 or something, 1998, it actually grabbed its hands in many corporate companies and a lot of big giant companies, right? They started using Linux operating system, and they started developing a lot of projects, applications, everything on Linux platform. And even if you see that the embedded world, right? Even the embedded world also grabbed its hands onto the Linux itself. And you know that once we talk about embedded, right, a lot of things comes to our mind. Like so, say for example, the IoT devices, right? Many of the customized application, many of the customized operating system, everything you need to do on embedded world. So those things started coming up, and Linux was the choice as a first choice to make use that operating system into the embedded world, right? And even like that once the Linux came into the picture, right, that the next operating system which came was an Android OS, right? Android was become very popular, and that in every mobile device Android is installed, right? So Android, the base was Linux itself actually, and a lot of SoCs, system on chip, applications, libraries were all written for Android, and Android itself was something like we call it as an OS itself. But below the Android, actually, Linux kernel or Linux OS is the one which is running actually. So now what happened? So Linux become very popular, and a lot of companies were started using, and you see that actually slowly most of the traditional Unix which were used earlier, right, like IBM-AX or HPUX or SCO Unix or many other Unix flavors which were using in the market or which is used by the customers, right? They started migrating into the Linux. It means that from the Solaris, they started shifting to the Linux. From IBM-AX, they started shifting to the Linux because they understood the importance of Linux, like in the current time. So now you see that most of the companies they've already migrated to the Linux, and you will not see any companies where they're using some older Unix flavors. Some companies are there, still they are managing it, but you could see that 95% of the companies they already switched to the Linux, and Linux is everywhere now. So that's the reason now what happened, it has become very important that we do a development. We do the development of the applications. We do the development of application. Application means I would say that like front end application, back end application, anything, all right, everything, right, is developed on Linux platform. So the popularity started growing, and you could see that there are many tools are there, right, which actually works only on Linux. It doesn't work on any other operating system. Say for example, Kubernetes. You can install Kubernetes master only on Linux. You cannot install in any other flavor, right? Like for example, you cannot install in Windows. So many of the softwares, tools, and are designed on Linux itself. And since a lot of companies have started using Linux, so of course there was a huge requirement on Linux and Linux administration and everything. Linux support people who knows everything on Linux, Linux automation. A lot of people who works on Linux shell scripting. So there was huge requirement started later, and you could see that a lot of people they started learning Linux heavily, and a lot of different even like the examination or the certification came in market. People started using people started going through the certificate, they started clearing the certification like that. So Linux become very popular, and today time also, even today also, you know that without Linux you cannot work now, right? You have to have a Linux knowledge. It's very important, right? So I'm not saying that you shouldn't have a knowledge on other operating systems. Say for example, you might even need a requirement of learning on Mac OS, on Windows OS, and some of the other flavors of operating systems are there. You should have a knowledge. But Linux is the one which is the most used actually. So you could see that in 80% of the companies, right, Linux is heavily used in every project or in every application design, right? So they choose Linux itself. So that's the reason it is always become an important for a DevOps engineer to learn Linux. Linux is required, sir. Without Linux, actually, you cannot survive in on DevOps or on cloud, right? So that's the reason we have to learn Linux. Now the question comes right into up to which level a DevOps engineer have to learn Linux. Is it something like we have to go in a very in-depth? Not required initially, I would say, but yes, definitely once you start working on Linux, there's an expectation from your end, from the company, that any person who is in DevOps, right, he should have a very good Linux administration knowledge. So uh, the level of understanding Linux for DevOps or cloud ops engineer. So what level, or what are the things? What are the things which the company is expecting from you? So you should have some good understanding or good knowledge on Linux administration. Good knowledge. Good knowledge, it's not like practical, guys. It's something like you should implement it. It should something like you already did some practicals or implemented, right? Good knowledge or good working knowledge on Linux administration. I'm not saying that you need to be very core in Linux administration. It's not like that. For example, simple. For example, like you have two machines, how to communicate with two machines. You know that SSH is a protocol, right? Or else rsync is a command or the protocol, right? Or else what else there? You can even do with the telnet, but we don't really use it actually. So there are some commands or protocols are there which you have to learn it. This is something like a very basic. One machine, how you can communicate with other machine, or how to copy a files, or how to do it. So all those user administration between two machines you have to know. Plus, you should also have some basic knowledge on basic networking knowledge. And when it comes to administration, guys, few of the things you should know. Say, for example, in case of a servers, you should understand about the web servers, right? The basic understanding of web server, how the web server works, what are the different web servers we have. Say, for example, you have Apache, you have Nginx. We have to understand about how to install and configure it, right? And what are the features the web servers provides to you. Similarly, like that, you have say many other servers. For example, NFS server, right? You have something known as a FTP server. What I'm saying, that some user administration knowledge. It means that you should know how these different types of servers work. Say, for example, I want to install NFS. So firstly, you need to know what NFS server does and what is an advantage of using NFS server, where in the industry, why we are using this NFS server in the industry, and how to install and configure it. And finally, suppose if you're working on NFS, how to troubleshoot it. So this thing is applicable for all the servers actually. Say for example, if I'm working on a web server, the same thing is applicable. It means that you have to learn how this web server works, how to install, how to configure it, why we are using web server, right, and how to troubleshoot it. So these are the some of the servers which you should know, like web server, NFS server, FTP server, right? What else you have? For example, Tomcat, Apache Tomcat server. This is one of the application server, app server, which we need to learn. And there are many other servers are there, but Tomcat server, Apache Tomcat server is a popular application server which we have today, right? And apart from that, what else you have? You need to understand the basic of what is HTTP, HTTPS protocol, how it works, what is this SSL certification, right? SSL certificate, how to install the SSL certificates. So all such basic things and encryption, decryption, whatever we come under this, right? All those things we have to learn, guys. Actually. Encryption, decryption. So it means that some user administration level knowledge. It means that some working knowledge where you have to install and configure some server up to some level. You should get it. Now the question comes, Rajesh, whether the interview, whether they'll ask it or not. Maybe they might ask it. They might not know. They might not. We don't know. But you should be ready to answer any question which has been asked in Linux. So this is one level. It means that some good administration knowledge, right? So, and also like, that like when we are learning on Linux, yeah, we should have a very good command, or we should have very good knowledge on command, good knowledge or good working knowledge on command. Without commands, that we will not be good knowledge on commands. There are many commands are there in Linux, all right? So how much to remember, how much to know, as per my understanding, right? Around 80 commands are there. 80 commands are sufficient for us to learn, to have a good command over Linux operating system, right? So it means that you have to start working on Linux by executing a command. You should know commands very well, and you should also understand why that command is used, where you are using, and what is an output you get. So we get an output from the executing command, but what is the use of that output of that command? You should know everything. Right. So this is one way. So initially, when you're going for an interview, sometime what happened, you will be gauged the knowledge of Linux by explaining about the command itself. It means that some interviewer might ask you, what is a command? Can you tell me? I need this kind of an output. Can you tell me, is there any command in Linux so that I will get certain output like that? So he will ask you through command. So if you're able to answer very well, right, what happened, right? He will get to know that okay, he has worked on Linux. That is the only way. Initially, they will try to gauge any person, that they'll start straight away. They'll start asking you Linux command. I think some of you might have already gone through some interview. Even they would have faced also. For me, multiple times I've faced because that when I put anything in my resume that I'm very good on Linux, so definitely they will ask me about the Linux command itself, right? And you should have a very good knowledge on commands also. Why? Because guys, again, that sometimes what happens in interview, they might ask you certain commands to you, and they will tell you to, or they'll ask you to explain the output of the command. So if you have worked on a system heavily on Linux side, you will be able to tell what is output for that command. Otherwise, what happens, it becomes very difficult. It means that they'll understand, they think that actually you have not worked very well on Linux. You are something like a guy who has copy pasted from document. You don't have a hold on Linux. That's what they will understand. So whenever you practice very well Linux, right, you should also observe what is the output of every command, what are the command you're executing, what is the output, what the output is all about. Somebody asks you should be able to tell also. That is one thing. And very important is that actually, like, say, for example, I'm just giving an example, like, suppose if somebody asks you, okay, I will take some randomly some name, guys, in our group. So I'll take Afzal itself. Afzal, can you tell me, like, in case of ls-l output, okay, this is one of the command Linux. What is the second column? What is the output? Means when you get an output, you will see that you will get a lot of columns. What is the second column of the ls-l output? You will say, sir, second column of ls-l output is done, but it gives you the information. Second columns, it will give you the information about the hard link. So it means that how many hard links are there for the file or a directory. That information you will get through the second column actually. Okay. Now you will say that he will ask you that what exactly the hard link is all about. Why we have a hard link? What is the difference between hard link and soft link? Hard link, what's the soft link? Difference between hard link and soft link, or we call it as a symbolic link. Hard link, soft link, you can even call it as a symbolic link. Sometimes we call it symbolic link, or I'm sorry, PLO, symbolic link. No, symbol. What is the spelling of BLOIG, right? Sorry, I'm forgetting the spelling. Symbolic.
SYMBOLIC.
LIC.
Ah, yeah.
BOLIC.
BOLIC. Yeah, thank you. Oh my God. How come I can forget the spelling itself? Very bad. If you're forgetting English spellings, no, it's very bad. So symbolic link. So like that way, guys. So that's what I would always say, that actually, that whenever you want to when you're working on DevOps or anything, right, you should be good on Linux, right? And also you should also be good on commands also. And as I just said, right, every day you need to learn Linux command. It means that every day some are the new commands you should be able to understand, or you should be able to execute and check it what the command does. So like that way, there are plenty of commands are there, but I would say that some 80 commands should be there on your fingertips. So when you're working on the Linux, 80 commands you should know most of the commands, but I'm just saying that 80 commands should be always be there in all your fingertips actually, so that you can effectively work on Linux operating system, right? So good knowledge on commands is required. Good knowledge, working knowledge on Linux administration is required. And the third important thing, which I would say that actually, okay, initially, you should learn on how the Bash shell script works. You should understand what the script does, how that script executes, and why we have the script. We have to understand that. Later, after some point of time, you should start writing the script. Actually, writing the script. It means that when you are involved in learning scripting very well, then the time comes that you should start working on writing shell script, because right, you are automating. So whenever you are automating, you have to, whenever you are doing any task manually, think about automating it. So the best is that implement the shell script to automate it. That's all this. Always. So I would see that a lot of people, they started learning and working on scripting, and over the period of time, say for example, after 6-7 months or in a period of 1 year, right, you will see that those guys become very smart, programmers. They become a smart script writers, and a lot of automation they were implemented in their organization or even in their team, right? So you will get a lot of appreciation, many things you're going to get through your company or through your management or through your lead, if you are automating the stuffs actually, right? That's what. So it means that when you're automating, then automating any task means it means that you're saving time. That is what they need it actually. And your script, it will be used by different people, different members within your team. Sometimes your script might also be used by some other team also, right? So sometimes you'll be involved where you'll start writing some global scripts, where your script will be used across your organization. It's not only for your team, across the organization. So that also is very good. And a lot of people have seen that who are writing such scripts to all the people. I have met, in fact, I have written many of the scripts across the globe. It means that in our entire organization, I have written. So those scripts were used by different teams for their different requirement, like that. Only have to change some parameter, so that script will work actually with very minimal changes. So any script you can, those scripts can be used by multiple different teams actually, right? So what I would conclude saying that actually, when you say that I am a DevOps engineer or I am a cloud ops engineer, I expect that this three minimum you should be known. Good administration skill sets, commands knowledge, and a lot of commands you need to learn, you should know. And the third important thing, that scripting. Apart from that, there are many other things are there, guys, in Linux, which I don't want to I don't want to really bring in, because you might think that okay, Linux itself is very heavy. It means that it itself will take a lot of time. So don't think in that way. Slowly, like if you guys are very new to Linux, or if you are having some intermediate knowledge on Linux, there are many, apart from these 3 points, there are many other things are there which you have to learn. But as of now, like, this is most important. This is sufficient for you. Anyone, like Afzal, you said that you are very new to Linux or something, right? You can start having these 3 things. It means that you need to learn the Linux administration part. Anyone commands every day will be learning. And third is nothing but you have to automate the things by writing shell script, right? So writing shell scripting, you have to learn very well effectively, because once you learn any one shell script, any one scripting language very clearly, and you have learned the entire thing, right? Then what happened? That will give you an edge to learn other scripting languages. Say today I'm very good in Bash shell scripting. Definitely I can learn the Python scripting very well. With little minimal effort, right? I'll be able to learn Python very well. So Python is the one which we have to learn. We all have to learn, and we all have to be we have to be good in Python, because tomorrow, like, companies they will ask you to write all automation tasks, everything in Python. Sometimes some companies say that actually, like, I don't need a shell script. I need only Python, because that's what they've started practicing in Python. It means that all automation they are implementing only through Python. So Python is having much more advantages than shell scripting, obviously. So that's the reason what happened. That I would request everyone that it's not only that you should stop only writing or become an expert in shell scripting. You have to move one step forward, and you need to start learning Python also very well. If you say, some of you say for example, if Abhishek says, I'm just taking a name, or as Ankit Reddy says that Rajesh, I can parallel run. Yeah, it's depend upon you how much you grasp it. You can learn parallelly. Shell scripting also can learn, Python also can learn. But yeah, I mean, what I would say, suggest that first you do shell scripting very well. 2-3 months you nicely practice and execute it, and then you switch over to Python. That's what I would say, because that will give an edge to you. It means that you already have some knowledge on shell scripting. Definitely it will benefit you to learn effectively the Python language. Is it clear, guys? So does it make sense, guys, for you? Any question you have so far? So I didn't explain about Unix and all. I'm just telling you that there was a traditional Unix operating system. Slowly Linux came to the market. It started grabbing the market, and most of the customer clients, most of the application, a lot of innovation, development activity, everything started happening on Linux itself. That's the reason what happened. Industry are looking for a guys who are very good on Linux actually. Because we all are into DevOps, or we all are into the cloud, we have to know Linux. There's no question about that. We should know Linux very well. And to what level we have to know, these are some of the 3 points which I have mentioned it. And finally, at the 4th point, I'm just saying that Python we have to learn. Already industries already started using Python. Already started using it. We don't have choice now. We have to even learn Python quickly. But anyhow, what I'm saying that we let us start with Bash shell scripting, then we can learn Python. Clear? Okay. Now, so in what level we are going to learn in this session? So I would be covering all these 3 points, guys. This is what I'm planning to cover it. It's not like that I will be covering all the servers. So I might cover few servers like not NFS server, FTP server, or web servers, right? Encryption, decryption, HTTP, HTTPS, SSL certificate, how to create, how to install it. All those things I'm going to show. These are some very, very basic minimal thing which you have to know, right? So, and also, like what I would suggest that guys, whenever you have free time, just go through all these different servers. So for example, FTP server, NFS server, how it works internally, right? What FTP server does, what is an advantage. Anyway, I will cover everything in the class, but I would suggest you also put some effort to learn, because you can do for one-time activity for learning, make a record of it, whatever you learned, and just keep that knowledge with you. Because see, you might not be doing in the organization, you might not be installing and configuring NFS server or FTP. Already these servers are already there in the organization. If you join any new company, it will be there. You need not to do anything. But still, what happened, whenever you attend an interview, interview point of view, they'll ask you from the very basic, very beginning. They'll ask you, have you installed NFS? What is the use of NFS? They'll ask you like that. Or what is the use of FTP server like that? So you should be able to tell. So these are some very impressive points which you can impress the interviewer by answering all such questions actually. So many times, yeah.
Sir, can you add two more servers, one of DNS and one Samba?
It will become too much, man. DNS server, no? DNS server.
No, but yeah.
I can add. What happened? I'll tell you. DNS server will take 1 hour. Samba server will take 1 hour. 1 hour it will take enough. 45 minutes you can cover. But what I'm saying that it will just, like it will increase our time actually. Or what I can do that these extra things and all, no, something extra things I can take in weekend, Saturday, Sunday. Just come for 1 hour. In between, whenever I'll say I've updated everything on Samba. I'll say that, hey guys, come this Saturday on. This Saturday, I'll be teaching you like that. I will in between, I'll keep calling you, because we all will be sitting for a longer duration of 3-4 months. We'll be sitting. So whenever there's a Saturday, Sunday there, I try to add something and I will call you. Just attend 1 hour and that's all. You learn one server. So I will see how good I can cover on Linux administration part. But what I will do that for our things to continue, it means that we have to switch to the DevOps, right? We have to start learning the DevOps tools. So for that, how much knowledge is required on Linux, that much I will cover it. Later, the extra parts and all, slowly we will cover one by one. We will not, it's not like that I will cover now only everything and then that's it. Because it will, if you are trying to do now, 1 month it will take for me to complete only on Linux only. So you'll all will get frustrated. What is it, Rajesh? You didn't start at DevOps only. Then you will say like that, right? Correct, guys? Did you agree with me? Ankit Reddy?
Yes, sir.
Kiran? Yeah. Munir?
Yes, Rajesh.
Milan? So fine, guys. So let us now start learning on Linux. Very important. So guys, so before I start it, I want to just understand about what is an operating system. Can anyone tell me what is an operating system? We have Windows operating system, we have Linux, we have a Mac OS. We say it is an operating system, right? What exactly an operating system is all about?
It is the middleware between the hardware and software.
Yeah, it is a middleware. Yeah, good, sir. It's a middleware.
It's interface between hardware and the user.
Yes. Middleware between hardware, user and the hardware, yes. It's a middleware or it's a software layer, you said?
System software that manage computer hardware and software resources.
Yeah.
Provides
So,
common services to computer programs, sir.
yeah, correct.
Isn't it?
So, yeah, Milan is saying, I think he has watched my video, he's saying about the same definition, what I said. I remember. So I say that operating system is a system software or it's a set of program or the model that controls and coordinate all the hardware resources for the different application program. So in my Linux recordings, I used to tell all these things actually. Yes,
Yes.
you're right, Milan. So it is like a system software or it's a set of programs that communicate to the hardware, right? That's all right. So operating system, guys, we know that it itself is a program actually. So OS itself is a program. You can say operating system itself is a executable program. We can say it's an executable program, no doubt. It's an executable program, right? And operating system, it compromises or it contains or it is nothing but it is a system software that controls and coordinates the hardware resources for different application programs. Right. So what it means that, guys, you know that we have so many hardware are there. Say, for example, if I take a laptop, right? So if I take a laptop, yeah, sorry. If I take a laptop itself, say for example, this is my laptop, right? So this laptop has a lot of hardware, right? You see that, you could see that actually in my laptop, like you have a lot of peripherals or hardware. Say for example, you have a keyboard, right? You have a screen, or we call it as a what is it, terminal, right? We have a lot of other devices in the hardware, like you know that there's a HDD hard disk drive is there, there is a RAM memory is there is a CPU is there, right? There are many other internal chips are available in the motherboard. Many other internal chips are there in the motherboard. All motherboard. What else you have? You have something like a NIC card. This is the network interface card we have. NIC card, right? Right. So we call the Ethernet card, right? And what else you have? You have mouse devices. You know that we use mouse. We use a lot of USB devices. We use, right? We use something like a pen drive or SCSI or SCSI devices, right? SCSI, SCSI devices. So what I'm trying to tell that there are so many hardwares are available in your system or in your laptop or in your server. So whenever this hardware machine or this hardware has to be communicated by the end user, say for example, this is an end user. End user is an end user, or we can call it as an application. End user application. Suppose I am a user. So Rajesh is a user. So Rajesh is an end user or the application. Whenever the end user or the application, it want to communicate with the below hardware. This is a below hardware. So what is hardware? Means all this keyboard, screen, HDD, RAM, CPU. So all these are hardware devices. All these are hardware devices. Right? It could be anything actually. Hardware devices could be anything. So whenever an end user want to communicate with the hardware, it cannot directly communicate with it. It cannot directly communicate with it. There has to be some interface. By using that interface only, the end user or the application can communicate with the hardware. And that is via with the help of a OS, operating system. Sorry, operating system. Operating system, it is a system software, or it is a set of programs, we say, that controls and coordinate the hardware resource for the different application programs. So here we are having only one user or one application. Like that way, we can have a multiple user or multiple applications would be running like this. Like this. There are many applications will be running, or many users have logged in. Whenever these users or n number of users, they want to communicate with the hardware like this, they can communicate with the hardware via with the help of OS, operating system. Without the operating system, the user, the end user or the application, they cannot communicate with the hardware. So now the thing says that, Rajesh, why we need to communicate with the hardware? See, as an end user, what you do? As an end user, what I'm going to do? So hardly you're going to run some application, right? You say that, Rajesh, I need to run an application. Fine, correct. You have to run some application, right? Run some application. Store the data. I want to store the data in hard disk. It means that you want to write something into the file. You want to store a file content, right? You want to communicate from one device to other device. Say, for example, I'm sitting in the laptop. I want to communicate through the internet. You need an Ethernet card, or you need an Ethernet card should be there in your system. It means that in your laptop, Ethernet card should be there. Without Ethernet card, you cannot communicate with the outside world. It means that you have to do some kind of a networking. So whenever you want to run some application, store some data, or you need to communicate with Ethernet card, like that, there are many stuffs are there where the end user want to achieve or he want to do. It can be done only via with the help of a hardware only. Without a hardware, a user cannot exist, right? He want to do multiple tasks. Without a hardware, he cannot do all those tasks. There has to be an hardware available. Now, end user, he cannot directly communicate with the hardware because hardware works in its own way and end user works in its own way. It means the hardware communication cannot be done because hardware understands its own hardware language, or we call it a machine understandable language. So hardware can only work, or you can work, or hardware works only through the machine understandable language. Right? So user doesn't understand, or the end user or the application doesn't understand this machine understandable language. Hence, what happened? An end user or the application, they cannot directly communicate with the hardware. So what we did, right? We got some interface or some software layer through which an end user or the application, it can communicate with that software layer that is done by the operating system. And finally, the operating system can communicate to the hardware. So there is a two-way of communication is happening, right? One is from your what is it? One is from your, what is it, guys? One is from your application to the operating system, and finally from the operating system to your hardware. So there is a two-way communication is happening here. Two-way communication. Do you agree with me? Right? There's a two-way communication happening here. So this is required. Two-way communication is required actually, right? So that's the reason what happened. Your operating system or the OS, it provides an environment to the end user or the application so that the end user can communicate with the hardware device. Right? It creates an environment. Right? So that's what I said, that operating system is a set of program or it's a system software that controls and coordinates the hardware resources for the different application program. There are a lot of application programs are there which has its own requirement, right? Some application requires some memory and some CPU. Some application might require more memory, more CPU, right? Some application will always require the CPU to run, means it will be keep executing always, right? So every application has its own requirement actually. Who is going to fulfill all those requirements? Your operating system has to fulfill all those requirements, right? So we have a lot of operating systems are there, right? Like Unix operating system, Windows operating system. Now it's Linux operating system, right? We need an operating system. So once you install this operating system in your laptop or in your server or anywhere, right? So through that operating system, you can actually now start communicating with the hardware devices. So how I'm able to type everything through the keyboard, because my operating system or the Windows or Linux operating system is helping me to type something. How I'm going to see the whole screen, right? Because my operating system is helping me to communicate with the screen or terminal. So this screen, right, whatever you're seeing, right, this desktop, this screen or the terminal, we say. So how we are communicating with, because there is something like with my operating system is helping me, or it is supporting me to communicate with my terminal or to the screen, we say, right? And you know that I can able to run any application. Once you started running an application, how we can able to run any application? Because with the help of an operating system. Without operating system, an end user cannot run any application. Say, for example, I want to open google.com. What I will do, I'll just do a double click on the Chrome browser. It'll open it. I'll just type google.com like this and enter. See, you're able to open the google.com web page. Now, how this thing is happening? It means that you're actually launching a browser, and there in the URL, you are giving a google.com. It means that you're actually executing some application or running some application. So whenever you run any application, right, the operating system has to be there. Without operating system, you cannot do any work, right? So as I said that your operating system is a executor program. It itself is a program. It will always be running, right? And the operating system is a system software, or it's a set of program or set of models, we say, which always communicates with the hardware. So now you might say that, Rajesh, how this communication is happening? Yes, we will discuss that later after some point around. But right now, you understand that whenever end user is doing some activity, he might be clicking onto the keyboard and he might be pressing something. He has opened a Notepad++. He's opening a Chrome browser. He's running a movie. He is opening an MS Paint and drawing something. So whatever the activity user is doing, the operating system is helping that user to do that activity. So like that, you have to understand, right? So this is very important, guys, because we have to learn the basic from the operating system itself, and then slowly we can go further in learning, in learning other concept of operating system and other concepts on onto the Linux operating system, right? So we will be learning all these things. We will see how exactly the communication happened, everything, which is to some extent it is required. Actually, I'm not saying that we have to go in depth actually, but to some extent it is required. Clear? Now, this operating system, guys, this operating system itself is a program or it's a model, as I said, right? This operating system itself has 5 important models, or we can say 5 important subsystems. So how the operating system is written? So there are 5 models or 5 subsystems, you can say, right? What are those files? What are those subsystems? The first is nothing but it is a file management, process management. I know some of you already know this, right? Because some of you might have gone through videos or something where you will see that same thing I would have told in many videos. File management, memory management, process management. After process management, you have a memory management. Fourth is a device management. And the last is a network management. So you take any operating system like Windows or Linux or Mac OS or any operating system, you see that you will see that these are the 5 important subsystem you will find in each and every operating system. So it means that your operating system is made up of these 5 subsystems: file management, process management, memory management, device management, and network management. Right? So we can, to just sound in a better way, first let me write a process management and then file management. Right? And then you write a file management. Process management, file management, memory management. So, Rajesh, do you have to really learn all these things? Not really required, not much in depth. Just one line information is sufficient for us. So we are not really getting into depth of all this things because we are just like a user, right? End user. I need not to really know about internally how this operating system works or how it is designed, made up of. Why I need to learn? Because as a DevOps engineer or the cloud, I need not to really bother about all these things. So it is not really required. But if anyone is a system programmer, if he's working in a system level, then definitely he will be learning all these things. So usually what happens in an organization, right? In an organization, if you get into any organization, you will see there are two important categories or two important set of people will be there who will be working in an organization. So what are those? So one will be like an application developer or application development or developer, right? So you could see that in organization, there are many people are there who are working as an application developer, right? You could see that a lot of people are Android developer, Android web application developer, or Android app development. They'll be working on Android app development. Many people are working on something like developing an application. So they'll write a front end and the back end of application, right? So I think you many of you heard about the full stack developer, right? There is a requirement, full stack developer, right? There are a lot of job requirements are there, right? And you will see that this full stack developer people know, they will know both front end and back end of the application. So front end, you can use something like a Node.js, React.js, AngularJS. You might have heard about these languages, right? And also, like for example, HTML, right? XML. There are many are there which we will be using as a front end developer. It means that whenever you want to develop the front end of the application, we will be using some of the languages like this, right, to develop it. And you are having a lot of frameworks to develop it for the front end application. Even like any web-based application, you can even develop through the Django, Python, Django framework for developing an application. So there are many other. I'm just telling few stuff. So you'll find a category of the people in the organization who call them as a front-end developer who knows many of these languages, and they started developing this application. Similarly, in the back-end application, like you will see that a lot of Java developers you have seen, right? Java developers, or else who, like Python developers, C++ developer, C developers, right? What else? Other language you have, like Go language, Golang, right? Go language developers. You will see that there are so many .NET framework application like that, .NET framework. There are so many languages are there, guys. By using that language, you can develop the back end of the application. See, back end of the application is basically, it is your core business or your the logic behind the application, right? Whatever the logic you build, right? That you need to build using this any of these languages, which we call the back-end programming language. Say, for example, Java you use, or else you use Python or C++ or .NET, right? Anything. So using this, you can actually develop the back end of the application where exactly you are writing all your business logics and everything, right? Where actually your application will run, right? So your application runs or execute with the help of the backend, right? And the backend is always written in this language. So you'll see this category of the people who you call it as an application developer, or you call it even you call it a developer, or you can even call it a programmer also. So these are the section of the people where you'll find many, right, who are all working. And the second one is nothing but the system level programming or system programmer. So system programmer, the one who actually will be working on to the operating system level. So you might have seen that many people are working on things like, for example, like onto the Android development they are doing. So they'll be working internal into the operating system core level, they'll be working Android developers, or else, for example, a lot of people will be writing some Linux or device developer programming, like that. So, and also like on to the Linux kernel level programmers. So this section of the people who will work more onto the system level actually. So they will also try to write the operating system itself. Suppose you want to write your own operating system, you can write the own operating system also. So a lot of people are available, are there in industry who are all working onto the core level on working on the operating system itself. It means that whenever you want to design an operating system or do any changes to the operating system, add some code to the operating system, right? Or you want to customize the operating system code, everything. So you will call them as a system level programmer or system programmer. This section of the people, you will not find that much huge number as the application developer, but yes, industries are there where you will see a lot of system level programs all are working. Like for example, suppose somebody might be doing a core network programmer. You will see in an organization who are working, right? Core network programmer, networking programmer, or network programmer, right? You will be seeing that. The percentage of the system level programmer are very less compared to the application level developer or programmer. You will find very less. Like if you say 70% of the people are into the application level developer, means only 30% of the people you will see onto the system level program. Right. Apart from that, you will find many people like support engineers, support engineers, admins, DevOps, like that, or the cloud ops. You will find many other different people who are working on the other level of work at the industry. Right. So we fall under this category, that is a DevOps, the third level, and we always support on the application side mostly. System side, there are developers, DevOps engineers are there who work on system side, but you will see that in very few companies. Say, for example, you might have heard about the NetApp company, right? You might have heard about a company by name Qualcomm, or else you might have heard about a company by name TVO, right? AMD company, right? Intel company. There are many product-based companies are there who are working core onto the system level. They also need some DevOps engineer. And I want to tell you one thing, guys. People who are working on this company as a DevOps, they are very highly paid compared to other companies. Very, very highly paid, right? Even people are working at DevOps, even in Microsoft also, a lot of people are working, right? So like that. So when the DevOps engineer works onto the system level, supporting a system level, helping the developers to do all those build activity into the system level, they also learn all these activity. They also know very well, and they will help the developers to do the all kind of a task what is required onto the system level, right? And you will see that those DevOps engineers are mostly working on in these companies actually, right? See, the requirements are very less because the number of percentage of the people working on the system are very less. Even you'll also see that the DevOps engineers who are working on this level are also very less. You won't see any masses of the DevOps people who are working on system level. No, very few are there, and they are stricted to that organization in Qualcomm or somewhere. They are working for a long time there only. Right? They know that like they're highly paid and all, and they won't get this kind of a salary in other companies. They know that. So hence you will see that these companies, these people, DevOps engineer, they all are stick to the same and they will never change. And they'll be working for a very long time actually. So like that. So if some of you will get into this level, by luck, you get into it to this companies and you start working on as a DevOps engineer onto the system level programming or helping out to work on all to system level, I think that would be also be a good job for you. So you should be lucky enough to get the opportunity and into that level. So why I said all these things, because guys, when you see the application, the end user application, operating system and the hardware, right, you will see that some DevOps engineer or some developers are working in the very upper layer here, like end user or application, which is nothing but the front end, back end, which I discussed now, this one, this part. So they'll be working in this level, this layer. And this layer, the system layer, system programmer or some DevOps who are working on to the system level, they'll be either working on operating system level or the hardware level. So there are DevOps engineers are there who will be having a very good understanding on operating system level and the hardware level. Prior that, they are working with help with the system level programmer. So guys, is it fine? Milan, Munir, did you understood whatever I said till now? It was required, guys. Why I want to tell you? Because broadly, I want to distinguish what level of different levels we have: application level developers, and system level developers. Like this, you should know it.
Yes.
So I'm not saying that you should get into all these things and learn it. I'm just telling you, maybe I would have spent some 10-15 minutes of time in giving this information. But definitely somewhere in, when you're working or when you're working on organization, you will come across with such people where they're working on system level, application level. Then you should broadly classify them. Okay, these are the people who work on the core operating system level or on core system level, right? And you will see many people, but 90% of the DevOps, you will see that 90 to 95, they all are working on this level only. Right? See, even I'm also working on the application level only. I'm not working on a system level program. I never get an opportunity, but I have a knowledge, but I never get chance to work under the system level. It means that as a DevOps engineer working on system level. But I have my friends who are working on TVO, Qualcomm, AMD and all. My friends are working and they share a lot of information and information about what they do, the work. And I found very fascinated the kind of work what they're doing. So that's the reason I thought that I will add this also to just let you know. Okay. So this is what I just want to tell you guys. Okay. Now, coming back here, sorry, I went somewhere tangentially, somewhere I went to this, but we'll come back to the operating system level. So operating system, as I said, right, there are 5 important subsystems are there. And Rajesh, you say that, Rajesh, if I learn and understand this 5 subsystem, are you saying that I become something like a good in system level programmer? Yes, guys, that's right. If you are learning about this 5 subsystem very well, you will get to know about this system level programmer. Then what about this, Rajesh? I want to be very good in application development, DevOps engineer, something like that. Learn about some programming language, learn about Java, learn about Python, learn about Go, learn about some Django framework. You will become very good in application development. You will also know how exactly you can help out or how you can better contribute if you are being a DevOps engineer. You will get you'll get that idea actually. That's what, if you learn any programming language, okay, even being DevOps engineer, that will definitely help you a lot in fixing many issues when you're working on the real time. Right? So people who knows about this 5 subsystem very well, they will know about the system level program also very well. So do you say that, Rajesh, whoever are working on as a developer, as a system level or onto the Linux kernel level programmer, are they good in this 5 subsystem? Yes, sir. They all are good in this 5 subsystems. Clear? Now, being a DevOps engineer, how much I should know? I need not to know much in depth, man, because mostly we all fall under this only. Why I have to break my head in learning all these things much? But just one line information is sufficient for us to understand, because we come across this process, memory, file, network, this kind of a words, we will frequently come across with these words when we are working as a DevOps engineer, right? Do you agree with me? Process, what is a process? File, memory, device. Memory also, many times we come across with this word memory, right? Because sometimes what happened, you being a DevOps engineer, your developer might say that, okay, can you get me the core dump file? Okay, your application has crashed. The application has crashed. Application has crashed. Can you get me the core dump file? You'll say. Okay, you'll get it. How to get it? There's a way, there's a process for that. You will get it. Okay, fine. Now, sometime your developer might ask that, please get me a thread dump. Please get me a heap dump. He might ask you, please get me the heap dump. So thread dump, there is a command in Linux. Suppose if you are working on Java application, right? There is a command by name jstack. Command is there. Using jstack, you can get the thread dump. Normally for the heap dump, right? You have something like a hdprof command is there. hdprof is there. Using that, you can get the heap dump also. Right. So now what I'm trying to tell over here is that, guys, actually that you will come across with some terminologies where you need to understand about what the terminology is all about. Then what happened, right? When you're working on the real time, you might come across with various different activities where the developer will ask you to do it. For example, he will say that, okay, every 5-10 minutes, please get me the thread dump of the application. So we will learn about all these things. What is thread dump, heap dump, what is this cold dump and all. We will see it later, not now. Maybe in some session, maybe in Jenkins and all, or somewhere where I will come across with these terminologies. I will say that what is thread dump, heap dump, right? We will discuss all these things, right? So that's the reason, guys. What happened that you should understand some of the terminology like process, file, and all, so that you will be able to better understand how things works when you're working as a DevOps engineer, right? Now, these are the 5 important subsystems. Good. Now, can we understand just one line information about what is this all 5 subsystems so that we will quickly understand and we will proceed further. Okay. Now, process management, this is one of the subsystem of your operating system, right? Where what happened, right? It takes care of creating the processes. It takes care of creating the process, okay, running the process, or what else? Having internal communication between 2 processes, and terminating the processes. So, guys, what is a process? Can anyone tell me what is the definition about the process? I'm sure that you might have heard about this process, right? A lot of time when you're working, right? Being a DevOps engineer or whatever, even if you worked as a support engineer or even anything, you worked as a database administrator, any profile you should have worked, right? You would have come across with this word process. Can anyone give?
Launching an instance or application.
Yes, very good. Launching an application or instance, something. Yes, good. Launching the application or instance, something is saying. Okay.
A program which is in running.
Very good, sir. Program which is running. A program which is executing, right? So you could see that actually, guys, there are a lot of applications which are running in my system, right? In this Windows operating system. Now, if I do a right click here and if I go to the task manager, right? Can you see that there are so many processes are running? This is something like a background process which is running, and this is something like a foreground process which is running. So here it is saying that currently there are some processes which are running, and these are the processes which are running in the background. So these are not the processes. It means that whenever you are executing any task or any application, whenever you are executing any task or the application, there has to be process for that. It means that there has to be some kind of a process which actually executes on behalf of your application. Say, for example, if I want to open the google.com, what you will do? You will do a double click onto this Chrome browser, and then you do a google.com. Simple. So you're trying to run an application. Now, how this browser application has been launched, how this browser is running, because that when you do a double click, actually, what your Windows operating system has did, that Windows operating system has created a process for that. So a process will take care of launching this browser. The process will take care of any kind of a URL which the user read, right? A user is executing the google.com into the taskbar here. So when you type it and you say enter, web page is getting opened. How all this is happening? Because there's a process which has been created. A process will take care of it. So as somebody said that a process is a running program. That is right. So what you have to say that a process is done, but it is a running instance of a program in memory. We call it a process. Or a program in execution. This is very important, guys. I don't know. I mean, earlier they used to ask this definition. Nowadays, they stopped asking this. Program in execution, we call it as a process. So whenever you try to do any task in an operating system, or as an end user, you're trying to execute anything, there has to be a process. Without a process, your operating system cannot execute any task at all. Like that, I have to say. So whenever you want to run any application or the program or any task, there has to be process has to be created. And who's going to create that process? The process is going to be created by your process management subsystem of your operating system. So there is a process management module is there in your operating system that will take care of creating the process, running the process, having an internal communication between 2 processes, and terminating the process. So once you have completed a task, once you have completed executing your program, the process has to be terminated. So here something like I open the browser, a process has created. Now I don't want this browser. If I just close it, even the process will get terminated. And when the process will get killed, it get terminated. So, and what I said right here in this definition, process management will also involve in having internal communication between two different processes. So it means that sometime what happened, guys, there is a requirement in your with you that if you are having two different processes like this, process A and process B like this, process A and process B. If these two processes it want to communicate with each other, if this process want to communicate with each other, even then also the process management will take care of communicating. How it communicates or what is there are various mechanisms are there. I need not to really get in detail. There is something like an IPC, inter-process communication mechanism is there. Using that also, a communication happen between two different processes. Say for example, in under IPC you have something like pipes. You have ports. Number 4. Some ports. SHQs. Shared memory. So these are some of the IPC, inter-process communication techniques. Using any of these techniques or using any of this mechanism, we can make use of communicating between two different processes. So sometime you might ask, Rajesh, what is the need of having communication between two different processes? Yes, there is a need, guys. Why is it? I will tell you later, actually, not now. Clear? So the process management, even I think, have you heard of the scheduling of the process? You know, a lot of processes are getting scheduled. A lot of processes will go to running state. Some process will go to kill, stop state, something like that. That we call the scheduling of the processes. It means that every time, whenever any process is launched, so some time slice or time has to be given. What is that? Some time slice have to be given. It means it has to get some time slice to run. This time slice, who is going to decide how much time slice should be given? That is decided by one of the component in your process management, which we call it as a scheduler. What we call? We call it as a scheduler. We call it as a process scheduler. So process scheduler is also a part of the process. So scheduling of the process is also taken care of by the process management. But process management inside, there is a scheduler component is there. Right, there's scheduling algorithm is there, or it's a program is there which will be running that will take care of scheduling of the processes. So guys, till here, any doubt you have? Process management, I just gave a 2-line information about what is the process management. Apart from that, you need not to know anything extra. Milan, Narendra, any question you have? Don't worry, guys. In the first class, right, you might think that why we are learning all these things. Over a time, after some time, you will see the importance of understanding all this concept. What I'm saying, it is required. At least at the basic entry level is required. We need not to go in depth. It is not required, but just entry level. 1-line information. If somebody asks you, you should be able to tell them. That's all. Not more than that. Firstly, nobody will ask you. If somebody asks you, you can give that 1-line information. Right? So similarly, you have a file management. File management is something like where you can create a file. You know, like always you get into some folders, right? Here I'll do a right click and I can create a text file. See, you're able to create a file. You can even rename the file, right? You can store that file. You can store the file content. You can create a folder. You can remove the folder. You can remove the file. You are doing so many operations, right? While sitting in a system, right? Similarly, Linux also, I create so many things. I create a file actually. How to create a file? There are a lot of commands are there to create a file. Say, for example, touch command is there to create a file, right? There is a sign by name, greater sign is there to create a file, right? For example, you can even create a file by using cat command, echo command, less command, more command. Even you can create with the help of a vim command, va command or vim vc, right? You can even create a file by name nano command. Like that, so many commands are there to create a file. Similarly, you have a commands like mkdir command to create a directory. You have a ln command to create a soft link, hard link, ln-s. You can have a mknode command, mkfifo command. Like that, we will come across many of the commands, msock command. So these are some of the commands which are used for creating a files and directories. Similarly, if I want to remove a file or a data, I'll use rmdir command or rm command with a -r option, f option like this. So what I'm trying to tell that you're playing around with a lot of files and directories. You want to store a file, you want to create a file first, you want to store some content or data into the file. Later you want to move that file, you want to copy that file from one location to other location. You want to delete that file. You are doing multiple operation onto the files and the directory. Who will take care of it? Your file management will take care of it. So file management is one of the system, or is one of the subsystem of your operating system, which take care of all your file management. And how the file management works with help of a file system software. File system software. What is it? File system software. So you have so many different types of file systems are there, right? For Windows, you know that earlier for Windows, we had a file system like MS-DOS, right? VFAT file system, right? Now we have something as NTFS file system. Similarly, for Linux file system, Linux FS, we say, we have a lot of file systems. Like we have a ext file system. Now we have ext4 file system, ext2, ext3, ext4. Extended file system, we say, ext4 file system, Razor file system, like that, right? We have some special types of file systems also are there. Special file system, what are those? File system, prop file system, like that. Razor FS, we say, sorry, Razor file system. Right? So like that, lot of file system softwares are there. Those file system softwares will do all your activity, whatever you need to do onto the file or a directory. So Rajesh, does this file system, whatever you're saying, this will do all this activity? Yes, sir. You can, whatever the commands you're executing, that is actually executed by your file system itself. So does the file system is the one which is going to do all this operation, whatever. Suppose I want to create a file, I want to create a directory. Does in Linux ext4 file system will take care of creating a file, create a directory and all? Yes, that is a file system software. Okay. So Rajesh, do I have to learn all this file system in depth? No, not required. So whether I have to learn all these commands which does the operation? Yes, we have to learn, because we are a DevOps engineer. We should know all those commands. So we should know as an end user, all the commands related to the file system, I should know. Similarly, as an end user, all the commands related to the process management, I should know. Okay. As an end user, as a DevOps engineer, I should know all the commands related to the memory management. I should know all the commands related to the network management. So do I have to know all the commands related to device management? No, not required. For DevOps engineer, it is not required. But if you're working as a system level DevOps engineer, then you need to know some commands related to device management. Signals is required, sir. Yes, signals are there. I mean, that's fine, sir. It's something I might miss actually. That's okay. So signals are there. Signals is also there in process management. Yes, good. Right. Signal is one of the way of the communicating actually. It's a faster way of communicating. Right. There are a lot of signals are there in Linux systems. We will discuss about that also after some time, not now. Right. So guys, did you understood about the process management, the file management at the very high level? Sandeep Aroda, Sadanand? Farin?
Yes, sir.
Yes, Raj.
Any doubt, anything is going in your mind, any confusion or something, or are you, sir, madam and sir, everyone I'm asking, are you feeling difficulty in understanding what I'm saying? Be truthful.
No, Rajesh.
It's
No, sir.
simple, right?
Yes, we
Okay.
already working on, so we are aware most of
Very
the
good,
thing.
sir. Very good, very good. Yeah, you are aware already. Yes. But for others who are very newbie, you have to understand from the very high level. I'm telling you, have to understand this. Slowly, if we get into the system level, like it means that if you started working on Linux, then all these things, whatever we learned, right, it will come as a part of our work. When you're working on a system, right, definitely we will come up with all this work, all this terms or all this concept, whatever you learned, right, we have to come across with that, right? Okay, good. Now, so memory management, you know that we whenever any process is created, right? See, for example, as I said, right, whenever you are executing any task, if you're doing any task, right? Suppose, for example, I'm launching a browser. So how this browser is getting launched? Because with the help of a process, we say. Yes, that is correct. So Rajesh, process management will take care of creating the browser or running this browser. Yes, right. That is correct. Now it means that for the browser to execute, the browser needs some memory, right? Without a memory, how the browser can run, how the browser can execute it. So for that, for process management or for the process, you need a memory. Who are going to give the memory to each and every process? The process management model or the process management subsystem of the operating system will take care of allocating the allocating the memory, deallocating the memory, right? Transformation of your data from your primary memory to the secondary memory, from the secondary memory to the primary, all those things is taken care by the memory management, right? So what is it? Okay, allocation of the memory, allocation and deallocation of the memory, right? What else? Then transformation of the data, transformation of data from main memory to secondary memory. What do you mean by main memory to secondary memory or secondary memory to main memory? What is it? Can anyone tell me? If anyone has idea?
RAM
Yeah.
to hardware.
Yes, very good. From RAM to hardware. Yes, right. So you have a RAM memory, right? And you have a hard disk memory, right? RAM memory is a volatile memory, we say, right? RAM is a volatile memory. Hard disk, what is a hard disk? It's a secondary memory. It's a permanent memory, we say. Secondary disk or hard disk is a permanent memory. So it means that if you're trying to store any data into a hard disk, it will be permanently stored into the disk. It means that the data will not be lost. In case of a RAM memory, what happened, right? It's a volatile memory, we say. Volatile memory means whatever the data which exists in the RAM memory, right? Right? You're going to lose the memory if your power goes off. Suppose your system is up and running, suddenly the power goes off and there is no backup also, your battery backup. So whatever the data which exists in your RAM memory, right, that will go off. That will be erased because it is the data which is there in the RAM memory or the data which is running the RAM memory, it is not stored permanently because RAM is not used to store any data permanently. It's a volatile memory, we say, right? So now whenever any data has to be copied from your RAM memory to your hard disk, right, there has to be some software. And who is that software? Your memory management, which is one of the subsystem of your operating system that will take care of transformation of the data from your main memory to the hard disk or from the hard disk to the main memory. Sometimes you want to copy the data from your hard disk to your main memory, RAM memory. Then also this memory management will take care of doing this transformation of the data, right? So again, as I said, right, we need not to really bother about all these things. We need not to really know, right? We need not to really, but just for, for just understanding purpose, online information is. So device management, yes, you're having so many hardware devices as I discussed, right? You're having so many different hardwares are there: keyboard, screen, RAM, CPU, internal chip, motherboard, NIC card, mouse, Ethernet, USB, SCSI devices. So many hardwares are there. Whenever an end user, he want to communicate with all these hardware devices, he can communicate with the help of an operating system that we already discussed, right? So, but within operating system, who is the one who's going to actually execute or actually communicate with the device? The device management. So the device management subsystem of your operating system will take care of communicating with this device. So device management will communicate with all the physical devices with the help of device drivers. Every devices, there is a device driver for that. Keyboard, there's a keyboard device driver. Screen terminal, there's a driver is there, device driver. So Rajesh, device driver is a program. Yes, it's a program. It's a part of your device management subsystem. Okay. Network card, NIC card or Ethernet card. So there's a network driver is there which is running. Similarly, mouse, there's a mouse driver which is running. USB, there's a USB driver is running. SCSI, there's a SCSI driver is running. So for all these devices, there is a device driver software is running. That device driver will take off communicating with all your end devices. Now we'll say that, Rajesh, if the end user want to type something in the keyboard, he will press the keyboard. Now the communication will go to the operating system. Within operating system, you have a device management. Within a device management, you have a keyboard device driver. That keyboard device driver will communicate with your keyboard. Similarly, there is a terminal driver, or we call it a frame buffer driver. The frame buffer driver will communicate with your screen or the terminal devices. Similarly, you have a hard disk driver that will communicate with hard disk. Similarly, you have an internal chip. Say, for example, you have a NIC card. So NIC card is not an Ethernet card. There is a network driver is there, right? So, for example, you have a NIC card. There's a card by name RTL813 network card is there. So there is a RTL813 network driver is there which is running. So the driver will communicate with your network card. Similarly, mouse driver, there's a mouse driver will be there, that will become. So for every device to communicate, there has to be some device driver which is running as part of your device management. So Rajesh, whenever any hardware device has to be communicated, it has to be communicated via a device driver. Without a device driver software, a end user cannot communicate with any hardware. Okay, fine, good. So it means that Rajesh, there are so many devices are there. For every devices, is there any driver for it? Yes, there are drivers for it. Some are already pre-installed with an operating system. Sometimes what happens, some drivers will not be installed. You know that if you plug in any new device, right? Any new device, say for example, you go to the market and you bring some sound card, you know, like sound card, right? Go and just bring the sound card and plug in. Your operating system say that you will get a pop-up message that, hey, sound card is not available, install it. So it'll try to install it by its own, or else it'll ask you to install, you have to install it, right? So similarly, what happens? Suppose you bring any other device. Say, for example, you bring some PCI Express, PCI card, you get it. There's the PCI slots are there, right, in your motherboard, right? If you get any PCI-based cards, it'll ask you to install some PCI-based driver like that. Suppose you're going and you're in your market and you're bringing some new card, something like D-Link network card you're getting. That's a complete new card. You go and plug in your laptop or in your desktop, right? It'll ask you to install that device driver. So you need to install the D-Link related network driver. You have to install it. So sometimes it might automatically install it because that module is already there. It will install it, or else it will ask you to externally to install it. You will go and you'll connect to the internet and you'll try to search for that network driver and then you will install it. I think most of you have already did it, right? When you are managing your Windows operating system and all, right, you would have seen that you're installing so many different device drivers. Similarly, Linux, earlier when I was working, right, I used to install so many drivers by my own. So sometime, yeah, device driver, DevOps engineer, yeah, he might have to even install those drivers also. Sometimes it happens, right? So this device drive management will take care of communicating with all your hardware devices because it has all the device drivers for all the hardwares. Is it clear? Similarly, network management, you know that network management, whenever you want to communicate with any network devices, whenever you are coming across with any socket related things, so for example, socket programming, or else you know about something you are doing a HTTP or HTTP communication, right? Or any kind of a network protocol when you're communicating it, network protocol. Say, for example, you are working on TCP/IP protocol, right? So then what happened, right? You need a network management. Network management is one of the subsystem in your operating system, which does all your network programming related stuff. Let it be socket programming, let it be HTTP communication, let it be communicating with using any protocol, your network management is required. So now you will say that, Rajesh, in an operating system, we have this 5 subsystem, right? Process management, file management, memory, device management, and network management, right? Anything we missed? Nothing, right? 5 subsystems are there, right? Now you'll say that, Rajesh, if I remove this network management, still I can have my operating system, right? Because you said, I don't want this network management at all. I want to be a standalone machine, right? Yes, you can discard it. You can completely remove this network management only with the device management, memory management, file management, and process. With this 4 subsystem, you can still have an operating system. You can still work on a system, but it will be without network. With network, you need a with network stack. It means that you need to have this network management subsystem, right? So network management is an optional. It comes along when you're installing, but it is an optional. If you don't want while installing, you can completely discard it. It will remove. It will not install any component. It will not even build your network stack also. Nothing will be there. Only this 4 subsystem will be there. Yes, still things will work, but as I said, but it will be a kind of your standalone machine. You cannot communicate to any machine at all. You will not be in the network at all. But nowadays, now we know that without network, you cannot live only. You have to be as a part of some network actually, right? Your system or your device or anything. So you need to have the network management. Every operating system, let it be Windows, Mac OS, Linux, Unix, anything, it will be a part of some network management. It has to be there. There has to be network management, or there has to be that network management stack should be there in your operating system, we say. Without that, you cannot do any kind of a networking stuff, right? So guys, now, so this is all about the 5 subsystem, right? Now, what we say basically that this operating system, basically it is written in C language. Most of the operating systems are written in C language. Even today also, these operating systems are maintained, or a new version of operating systems are released by writing a C, by implementing through C language only. Some operating systems, they use the C++ also, right? Microsoft company, okay, they released this Windows 95, right? Windows 95 was written in C language only. Later, what happened, right? Microsoft came with their own language. Microsoft came with their own language, means that they designed their own language. Okay, and later, after Windows 95, say for example, Windows 98, Windows Vista, Windows XP, now we have Windows 10, Windows 11, whatever, right? It's all, they all implement that operating system, whatever they design, right? They do it through their own language, what they have designed it actually, right? Most of the Unix flavor operating system, right? Let it be Linux, Unix, HPX operating system, IBM X servers, Solaris, right? SCO Unix, Berkeley software distribution, Linux based OS, Fedora, Red Hat Linux, anything, all the Linux flavors, all Unix flavors, everything is written in C language only. All Unix flavors and Linux flavors, or Linux flavor, I mean, Linux based OS are written in C only. Clear? So, guys, I've already passed 10:30. I'll take another 5 minutes more to complete certain things, and then like we'll see tomorrow, like where we can we'll continue from tomorrow onwards. Okay. Now, see this operating system. The whole operating system is what I said. It is having this 5 subsystem, no doubt, right? These are 5 subsystem. So this 5 subsystem, they compromise together, or they are together, and they are called as a kernel actually. So your whole operating system, whatever the 5 subsystems you have, right? That all 5 subsystem together, we call it as a kernel actually. So kernel is a main core of your operating system. So 95% of the operating system OS is kernel only. So out of your 100% your kernel, right, or 100% of your operating system, whatever we have, right, 95% of the operating system is nothing but your kernel, plus 5% of your operating system code is nothing but we call it as a HAL. What you call HAL, hardware abstraction layer. Which is actually written in assembly language. If we are talking about x86 processor, right, this HL is written in x86 assembly level instruction. Assembly level instructions. So what is this HL and all? We need not to worry as of now. Just try to understand that your whole operating system is nothing but 95% of the operating system is nothing but the kernel itself. So if I say Linux operating system, or just say Linux, or just say kernel, all are one of the same. So from tomorrow onwards, if I say Linux kernel, it means that it is an operating system itself. Or if I just say Linux, it means that it is an operating system, or it's a kernel. Because the whole 5 components, whatever you're saying, right, it is nothing but it's a kernel itself. Actually. So tomorrow I might say that, oh, it's a Linux kernel, I can say like that, or Linux operating system, or just say Linux. Similarly, you can even say Windows also. Windows kernel also we can say, because even Windows also, it has all those 5 components, but Microsoft doesn't call it as a kernel. They never use this word kernel when they are representing the Windows operating system. They'll just say Windows. That's all. They will just say Microsoft operating system, like that. They will say. They will never say Microsoft kernel or Microsoft Windows kernel. They will never use this word kernel. You might have seen, right? In Microsoft, people doesn't use this word kernel because this kernel word was coined for the Unix flavor operating system itself. Because Unix also had this 5 subsystem, right? They call this as a kernel only because these 5 subsystems are the main core of your kernel, of your Unix operating system. So this word kernel was coined from there itself, from traditionally long back, right? When the Unix flavor came, right? Or when the Unix operating system was designed, at the time the word kernel was coined. The same word was carried forward even when the Linux was also evolved, or when the Linux came into the picture, right? We call it as a Linux as a kernel only. Clear, guys? So guys, this is all about what I thought I will cover, but I was thinking to cover many other things, but anyhow, that's fine. So tomorrow we will stick to the topic and I will try to cover as much as possible, okay, in Linux part. So in 1 or 2 sessions, you will see that I might add more theory, less practical, but moving forward in 3rd or 4th session, you will see that only practicals, less theory, more practical, because theory I have already covered many things. So we will be only practicing Linux only. So in 1 or 2 sessions, you will see, okay, Rajesh is speaking more, but practical is very less. Tomorrow also I will speak some, I'll make 50% practical I will do, 50% theoretical I will do. So one more thing, guys, I want to request from you all. Can we make tomorrow for 2 hours class? Is it fine? If you're okay, can we start at 8:30 to 10:30? If you're available. If not, 9 only will start. But please give me a time up to 9 to 10:45 or 10:50 max. Not more than that.
Sir, please 8:30, please.
No,
Because
I
my
want to
office
know
time
from.
is 11 p.m.
No, I want to know from everyone, Milan. Everyone have to say yes, yes, yes. Then I'll be very happy. All have to say yes, yes, yes.
Okay, sir.
Because if 1 or 2% says, sir, we can't win, then it doesn't look good actually.
Okay, I will join from my mobile.
Yeah, that's what like.
Okay,
Because I don't know how to ask you. I mean, guys, can you give me every day 2 hours for this Linux? Is Ashish,
sir.
Abhishek is available? Huh? Abhishek, Dayanand, Bhima, Niranjan. Niranjan, I know. Sir, just 2 hours, sir. I'll be very happy if you give me 2 hours. But I'll be covering many things and also like a lot of things we will be covering in Linux, right? So I need some time actually, more time. Yashar, is it fine for you? If because I'm taking too much, 2 hours is for some people. Yeah,
Yeah,
thank you.
Rajesh, it's fine. It's fine. It's okay. We can do that.
Yeah, but sir, today was it useful for you or you already knew something in today's session?
Yeah, it's really good. I think I know these basic things. I'm waiting for more. I think there will be coming more lectures and
Yes,
so
definitely.
far
We'll
so
cover. Yeah, we'll cover many things actually, no doubt in that. But that's all.
yeah, sure.
Today itself, I don't want to ask you for 2 hours because you will feel what is this. Today itself is asking, so that's the reason. Okay, fine. So we will see, guys, tomorrow. Then we'll stop the today's session then. Clear? So, guys, I think I'm not sure whether you have any doubts or not. I don't think so. You'll have any doubt because today is the first day, right? I just covered theoretically. Still, if you have any doubts, let me know. I'm available now. Yeah. Shini, Varun, Srinivas.
No doubts, sir.
No doubts, sir. Farin, any doubts you have?
No, Rajesh.
Okay, thank you. One more thing I want to tell you guys, to everyone, like in the last session, many of you left actually after the class, and after that, what happened, right? A lot of people were started asking some doubts, and I stopped that recording, and one of them said that, sir, please, you would have recorded even this also because some of the very important question they asked and which was not been recorded actually. So many people, what they told me on that day, it's Friday, that sir, please don't stop the recording when you're asking any question wrong, right? And you're answering it, and we need that also as a part of recording. So what I will do that after the class completes, I will wind up it and I will give only for questions. So if you ask any doubts or any question, right, that will also be on the recording only. So once you stop asking question, then I'll stop the recording. Is it fine with you all?
Yes, sir.
Yes,
Okay.
Rajesh.
Thank you all. So thank you guys. Then I think if no more question, we can stop it today's session. Tomorrow again we will meet by 8:30. Fine, right? All have agreed for 8:30, right? Yashar sir, you're agreed with 8:30, right?
Yeah, it's fine for me.
Thank you, sir. Thank you. Thank you, guys. Good night then. Thank you all. Bye.
Yeah, thank you. Thank you.
Okay, sir. Good night.
Good night. Bye. Thank you.
Good night, sir.
Yeah. Good night. So let me stop the recording.